Today I'm continuing with rslox, my Rust implementation of locks from the Crafting Interpreter's book. I'm going to look at some examples as well, just to kind of guide me, because although I've done some code in it already, as you've seen in a previous video, it's very messy, so I'll let it speak for itself. I mean, here's the this is the main loop, obviously very simple, but then here's the tokenizer module, which is, it's not terrible, but like it could be more streamlined. And right now it only supports very few symbols. So let me go ahead and open up the compiler as well. All right. Keywords, all that. Here's the main loop. Yeah, so before I go any further, let me go ahead to the book over here. And there should be examples. Somewhere. Crafting interpreters, implementations. Now it is kind of cheating to look at people's code, but like I'm not going to copy it. I just want to have a look. Tree walk interpreter, bytecode. Okay. Are these ordered in any particular way? What? Line by line ports of rslox to Rust. 1500 unsafe blocks. Why? I gotta see that. Okay. Source. Going straight to the scanner. Yeah, so they do also use a struct, as I did, or as I am, sorry. This is another one. What are different folders like this? Different like modules. No, what the hell? Okay, Lexer, tokens, mod. Wow, really quite modular. They also have a Lexer class, or struct rather, with an impl. Kind of messy though, so I don't want to look into it too much. And rslox rs. Learning Rust by doing it all wrong. Now this is how you do it. Oh my days. Repuate. It is using a match. Wow. Anyway, so this is the one I'm looking at right now that I want to focus on. So notice that I have my tokenizer here, tokenizer struct. I made it because I thought it would just make things a bit easier. And yep, sure enough, this guy also has a scanner with a source. As his is a string, mine's just a vector of chars. I immediately convert it. Tokens, yeah, vector tokens. I got the. I keep my errors here, but they have the start and all that stuff as well. So that's cool. I was quite worried about that, but looks like that seems to be okay. I wonder how they're doing their token. Is it just an enum? Create, report, token. Where's token? Where's that coming from? Different file. So their token has t-type, then a lexeme, literal, and line. Okay. Okay. I now feel better about my implementation. And yeah, stuff to advance, I guess. Add token. Bunch of matching. What's the B? Is that for ASCII? Is equal, if it's equal this, if okay, fairly straightforward. Rust B char literal. Byte string literal. I see. Yeah, they have C as a U8, not as a char. It's interesting. I wonder why. Why not just use chars? Seems a bit strange to me. I'll just keep using chars until I see reason not to. Okay, in that case I guess mine actually is fine. But I was thinking about like making this a bit more streamlined. Match here, yeah. Matches the next char. Advance. Does Rust have pipe syntax? Or piping? Okay. Does Rust support piping? Bro, how did I mess that up? Like literally line 1. Like this should be common knowledge. Okay. It's been discussed, but it might come. Okay, that's cool. Is it if it's on the horizon? So is there a way I can chain these? Or do I just keep them as separate lines? Why does it matter? It doesn't. But you know, just a thought. These 2 lines. If it returns itself. Yeah, that's why I would do that. I mean, that's why I don't like the builder pattern, because like it relies on you having this as the function signature. I'd prefer if you had an operator that automatically did that, like a piping operator. So then it would just look like this: tokenizer, add token, advance. Like that's it. Stuff like that. But anyway. So tokenizer, add token, then we advance. Yep. Next char index, tokenizer, current char +1. If tokenizer is input end at. Next char index. Then match. What? If tokenizer dot is input end at this place. Should probably say does input end at. Just be a bit easier to fucking make sense of that. Hold on. Why don't I change this one? Oh, okay, I have to do it globally. Does input end at this place? Shouldn't it be like the other way around? If it doesn't end at that place? Index is less than self.source.length. Yeah, this is inverted. Hold on. Index more than. So on this. Yeah, okay. Right, simple there. And ooh, I think it'll be greater or equal to actually. Index is greater or equal to source.length. Yeah, that's correct. Okay. And I'll see. I'll create another one. It's also backwards. Is input at end. How did I not notice that? I'm actually geeking out, tweaking out, geeked out. What the fuck? Does input end at next? Just simplify it. Don't need this then. Don't need this then. This. I think I don't need it. Yeah, I don't need it. Although it does look a bit weird. Whatever. Tokeniser.source, next char index. Get current char. Let's do get next char then. Tokeniser dot get next char. Tell you what, I'll call this add double token, and what that will do is auto advance twice. Because add token does this right now. Add double token will just self.advance as well. Yeah, it should advance automatically, really, so I shouldn't need to do that. I hate how you can't do overloading, man. Like, overloading is actually quite useful to have advance default, advance 2, you know, instead of to like advance n and type it out. And, like, it's like, what's it really hiding, you know? Step. Alright, let's do a quick compilation test here. Cargo run. Get warnings, but it does finish. It just seems to get stuck. Ugh. Just confirm cargo build, and then if I target / debug / rslox, yeah, infinite loop. Okay, so we get stuck here. Tokeniser dot is input at end, or is at end. If self.current chart index is greater or equal to self source hot length, self.current chart index is greater or equal to. So while it's not the end, do this. Yeah, that makes sense. And add token should consume and advance. Looks good to me. Add token, add token, add token. It's because of this. Alright, it works. You get token error because you have 2 unrecognized symbols. Let me just go ahead and remove those so I can test it properly, as if there were no errors. My camera's covering it, but it says okay. That's fine then. So yeah, everything still works. Okay. So here's our main loop. We define it here. There's always one at end, do all that stuff, and then at the end handle the errors. So it's pretty straightforward. It's just this stuff that's whatever. These names are goofy, but it's fine. Those are easy to fix, easy to change later. Let error. Yep, okay. So, where am I in the book right now? Did I even cover everything? I think I did actually. Do I need to add an end of file? I don't think I do. Like, why would I need an end of file token if I can just see when it's at the end, you know? Yeah, I don't see a reason to do that. Okay, so what's next? Alright, there's more white space to consider though. So if you get a space... Hold on. Yeah, these. So tabs, R's, and spaces. So where the fuck's my thing? Space or R return thing or tab. Just do nothing. Well, don't do nothing. Advance. Ignore it. I think that's how you do it in Rust. Could be wrong. Let's give it a try. Add some spaces to my thing. Put this on a tabs line. No, got an error. How do I match different things to the same output? Okay, it's just a single bar. Probably could have guessed that, to be fair. Compiled. Run it. Seems to work. We get parentheses starts. Well, let's just look at it for comparison there. There it is. So you get parentheses starts, then the operator plus, then an asterisk, then parentheses end, spaces ignored, brace starts, minus, bang. Whoops. And then you can't see this part, but it says brace end, and then new line is ignored, tab is ignored, and then, well, the line number isn't ignored. The line number increases for the new line, and then we got bang equals. So that seems to work. Okay. String literals. Now that we're comfortable with. Oh right, I need to also have like these other double tokens. So let me also organize those. So these operators, plus, minus, asterisk, bang. We should have a slash for divide. Bang for not, bang equals. What else? Does it say what else to include? There's a list, right? Yeah. I'm going to include all of these. So we got comma, dot, minus, plus, semicolon, slash, star. Now I put them here as operators, but to be fair, they're not guaranteed to be operators. They're kind of just like tokens. They could be anything really. Like a plus isn't necessarily an operator unless you have it in your unless in your language they are specifically operators. Like the period can be an operator for dot syntax, and that's actually it, I think. But like, what's an actual example? Like in C, the comma doubles both as an operator, the comma operator, which not many people are aware of, but it exists, and then the comma just like, you know, for like separating lists and stuff, for like function arguments, that kind of comma. So like those are two different uses of the comma, and there's no way for the tokenizer to differentiate. So there is an argument to just not have a separate operator thing. I'm trying to think, like, is the lecture can't really, like, the lecture could, I guess, deduce from context which one it belongs to, but like that's not its role, I don't think. Anyway, this language just doesn't have a comma operator, so I guess I'll just do what I actually have in front of me. Minus is only ever an operator, plus is only an operator, slash I think isn't. It said that slash is used for something else here. Oh, for comments, that's right. Yeah, so like where would you put that, you know? If I look at this guy's implementation and his token class, or there's your token class. Yeah, they just have it like this. So I think I should do the same. Identifier, string, number. I don't know why they don't just use the enums. Well, I guess because they're following this tutorial, but I don't know why they don't just make use of the enums there. Like literals are definitely going to be literals. Those are not disputable, and numbers are definitely numbers. Those are handled in the lexer stage. It's just these operators which aren't guaranteed to be operators. So paste that there. Remove these. Keywords as well can be on their own thing. That's completely fine. We've got these braces. Or brackets, as I like to call them personally. Symbols and operators. Really just miscellaneous. So we got slash, we got double slash. Right paren, left brace, right brace, these are single character tokens, comma, dot, minus, plus, semicolon, slash, star, bang, bang equals, equals, like double equals really, or is that different? Equal, okay. Equals, double equals, greater or equals, less and less equals. Okay. We have an identifier, string, number. Identifier, which is a string or a number. Okay. And a literal. Sorry, a literal is a string or a number, and identifier is always a string. So that's fine. And keywords are keywords, so those can be detected. And end of file, I'll just ignore because again, I don't see why I need that. So let's use that then. Remove that completely actually. So D2F boom, just do the same thing for all of them. And the extra parens around there. Okay, so then there's more to consider. I'll just look at this. So you got left parentheses, right parentheses, left brace, right brace, comma, dot, minus, plus, semicolon, slash, and star. Bit out of order, but that's intentional, don't worry. For the slash, it depends. We'll do if not tokenizer that does input and at next. then match tokeniser.get next char. If it's another comma, another slash, sorry, then we'll do tokeniser.add double token double slash. Otherwise, tokeniser.add normal token slash. Now at this point you may have noticed a slight issue, which is that if the input does end at the next, then we have a problem. The issue is that it will try to look for the next char even though the next char doesn't exist, which is a problem. And I guess that's where end of file could come in handy, I suppose. Or I could do where get next char. If there's nothing else, then what it will do is it will return a optional ooh. I could do this. So I would get rid of this, and instead I would have, if it's some thing, then do that, and then if it's either nothing or something else, then just do slash. What this does is get next char will return an option. If there's nothing there, it just says there's nothing there next, just leave it, or get something else, and then this covers both cases. And yeah, otherwise I need to like kind of repeat myself. I'm not sure how else I would get out of this. I'm not entirely sure I can, so at least like not easily, but this would be a pretty clean approach. Of course, it's a bit more verbose because I have to do some like this, but I think that's okay. And then I could align these. I suppose I might as well. Yeah, so let me change get next chart. Check here. If does input end at next. Whoops. Okay. Then early return none. This would be option char. Okay, thank you. Okay, thank you. Jesus Christ. I mean, having pattern matching is such a blessing. Otherwise, return some. Yeah, that's pretty clean. That works perfectly fine, I believe. So then I can. I want to put this on one line, but there's no like good way to do it. Like that. Just ask quality what it says. Is there a way to make this compact that is proper? Okay. I could match it cheaper, by the way. It did mention that, but let me think about that in a second. Like this, I guess. Yeah, that's fine. I don't know what I was worried about. Okay. Let me just double confirm that actually works. Cargo run. 179 if self. Right, yep. it works. Okay, so if I were to use a tuple, I could use a tuple actually. Yeah, why don't I use a tuple? I mean, I see why he doesn't in his Java thing, because he's using Java, but I could totally just match a tuple, right? I think I will. So I'll do get next char. Sorry. Let's see. Do I see beyond this? I don't. So I'll just do match tokenizer dot get current char, tokenizer dot get next char. That's a tuple. I know it looks a bit like fucked, hard to read because it kind of is. Let current char equal tokenizer dot get current char. Let next char yeah. I don't know if that's like helpful. I feel like that makes it easier to look at. Anyway, so the first one is just a raw char. The next one is a maybe char. So then I can do this instead. I can do boom, clap, what? Boom shakalaka. So if it's none, then we do tokenizer dot add token slash. So not none actually. Empty. But if it matches, and this have to be before, if this matches a double slash, so sum slash, then add double token, double slash, and look at that. Now we've separated them. Love it or hate it, it is straight bars. Like this, I guess. I like that. Same for the rest of these then. Yeah. So here I will turn record a shortcut. I think I just do control. Is it A? No. Is it just Q? Q1. Yeah. Boom, boom, boom. Shouldn't matter too much. That's it. And then go back to the start and go up. Okay, stop recording. The thing is A. Is it capital Q1? No, just capital Q. Okay. Yeah. Made a mistake apparently. Sick. Okay. I mean, I think that's pretty neat, isn't it? I like it personally. All right, and same thing for others then. So for the bang, if it's followed by some equal sign, then we do this. If it's not there, we just do this. Taking this thing and deleting the rest. Look at that. Look at how nice that is. Okay, to be fair, I guess the bad thing is that it's always looking for the next char, which can be a bit wasteful. I do see that. But this matching prevents double matching. Like, it prevents nested matching, which might be faster. Also, I don't really care. So then we have this, which is going to mess up my fucking spacing, but it's fine. It's a special case anyway. And these as well. They do not care what's next. almost wonder if the compiler can optimize. Probably not. Maybe. And then if there's anything else at all, then just token error. Cool. Let's give this a spin. Shit. Current char. Yep, that works. Cool. What else is there then? So there's more, right? Yes, there is. So we have slash, bang equal, bang 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 equal. Then we have equal equal and equal 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 equal. Jesus. So we'll place that. Place that. These bangs just become equals. I lied. Actually, I lied really hard. Actually, that's not the case at all. That's equals. This will be, whoops, double equals. Then we have greater, greater equals. So greater equals and greater. That's correct. So greater, this would be greater equals. Then same thing here, but just with less than. So just replace greater with less. And that's it, right? Then we just have the keywords and stuff. Yeah, that looks good. That does look good. I could collapse this. So it's like this. It means the double ones stand out. But then like this just becomes so fucking difficult to like fucking to read. So I'm not for that. Alright, Kojo build. Good. Actually, let me just look at these warnings real quick, because it might actually be significant. Unused, 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 unused. Never mind. Forget that. Yep, so that's cool, that works. Now we go to the next part, right? So literals. Back when I was preaching the gospel about error handling, we saw that we needed to tell users where errors occurred. Checking that starts here. In a simple interpreter, we notice only... Ooh, this is different. Sorry, the license for literal values, numbers and strings, and the like. Since scanners will walk each character in the literal to identify it, it can also convert the textual representation of a value to the runtime object that will be used. So this is... Okay. Sorry, I'm so ahead of this right now. I'm like here. We're still missing one operator for division. That character needs a little special handling because comments begin with a /2. Yeah. Oh yeah, and then a comment goes to the end of the line. So a comment has special behavior because it then will just ignore everything until the end of the line. So if I have a double slash, we are not adding a token. I was actually wrong. Double slash is not a token. No sir. You can tokenize comments if you want to, but this doesn't require it. So instead we will just tokeniser.advance until HR. Yep. You may be asking, what is that function, Kojo? We did not create that. I'm going to create it right now. Advance until lead self char target. So while while self dot get current char equals does not equal target, and while not is at end, and this self.advance. That's it. Okay. Consider using this method on self. I thought I did, man. Gotta get used to that. I don't love the self pollution, but at the same time, I do appreciate it making things explicit. Do you have to call it self? Yeah, I think you do. Like ergonomically, there is a case for just calling it like S or something. Like I know that, like I know that's really cryptic, right? But like it's things like these where, because it's so common, just having a way to just do it, like really like short would be cool. Like an at sign instead of self would be cool as well. Just something like that, you know. And this works. Let's see if it actually works though. By feeding it a comment. This is a comment. Cargo, run that bad boy. Plus asterisk, bang, brace end, brace equals. Yep, the comment is completely ignored. We are being chilling. Sick. I'm actually amazed at how well this is going already. Do I even need a semicolon? I don't know. I'm just gonna follow the tutorial. We've got another helper. Peak. Yeah, so he actually did use a null terminator for the end, but I don't care about that. Okay, so peak looks ahead. Comments select seams, but they are meaningful and the parsers don't want to deal with them. So when we reach the end of the comments, we don't call add token. When we loop back around, the next select seam strike gets reset, and the comment select seam disappears in a puff of smoke. Yeah. While we're at it, now's a good time to skip over these other meaningless new lines. We've already done this, that's fine. Okay. Right, string literals. Now that we're comfortable with longer leg seams, we're ready to tackle literals. We'll do strings first, since they always begin with a specific character. Before doing that, I just want to quickly check my messages. Okay, I'm gonna leave it around 10, about half an hour, give or take. If it's string, so it just calls a function. Okay, so to be fair, this is the one I have here. Looks like a very faithful recreation of what he's done. This is the wrong file. The fuck? Whoa. Okay. Notice that for the strings, self.string, right? So like, yeah, that's very faithful. I don't know why it's called string though. I call it like parse string personally. So this calls this function while peak is not equal this and if peak equals this, line plus advance. String value equals source of substring start current. Ooh, that's good, I think. Okay, so let me think about how I can do this one then. Now I have a vector of chars. Taking substring would be faster than constructing the chars one by one. No, I'm lying. I think I can take a slice and then convert that, and that should be fine, honestly. So let me just try that. I'll do it here. So when we reach a thingy, no matter what's next, double quotes, we do this. So while peak does not equal thingy, advance. Okay, so let start equal tokeniser dot get does it knows position actually? Current chart index. It does, yeah. Okay, so I don't know what I'm doing. Get current char index, and then while not actually, I'm going to do this right. Tokeniser dot advance until the next one. Not including the current one, right? So let me change this a bit. For advance until, it will advance first to get past the current one, and then it will continue to advance. So advance until will always advance at least once, which is good. So yeah, advance until then, and then take let end equals tokeniser dot current char index. Okay, if is at end. Actually, yeah. So if tokeniser dot is at end. Oh, that's what they call theirs too. Why did I call mine something else then? Tokeniser dot is at end. Then, I mean, I can vaguely remember why. It's kind of weird though. Then return. No, don't return. We're gonna push. Tokeniser dot errors dot get or insert with vec new. There has to be a better way to do this. Okay, let me just do push error. Taking the error type. So token error type. Unterminated string. Lock supports multi-line strings. Okay, that makes things convenient. That's what to say. Tokeniser dot current line number. Well, actually, I don't need that, do I? Because I can just check that myself. Cool. Just do that then. Nice. Okay, that should work. Then let end equals this. Right, so how do I take a substring of a vector of chars and then convert that back and then convert that into a string object? Very specific. In the meantime, let me just do this as well. Tokeniser dot push error. This. Then I can remove both of these. Whoops. Stuff. Yeah. Ain't that nice? Then I need to create it. Ooh. Okay, let me actually copy this first. Probably a good idea. So push error. Push error has immutable self and takes in an error token error. Just paste that in. Self.errors, get insert, effect new, push error. Okay, that should work there. Iter.collect. Sorry, so you can do chars 1 to 4.iter.collect, or you can do string from iter. I prefer that, yeah, that looks good. Very simple, isn't it? So then I just do tokeniser.add token literal string string. And then I'll say let string equal this thing. So string from iter, we take tokeniser dot source, right? Yep, that's the vector chars. Whoops. Dot source at slice start to end. Should work. Let's have a look. Kojo run. Token error type in the current scope. Token error type. Whoops. Issue is definitely here. Line 64. What's wrong? Alright, unterminated string. Okay, compiles. I could I'm actually surprised. I could actually pass the string to the error. Right? So let me do that. So I'll do this first, and then if it's at the end, then we'll do unterminated string with the string. Otherwise, we add a token like this. I could also simplify this, so like I don't have nested enum types, because like out of literals, I only have 2 literals, so I could just have string literal, which is a string, and then number literal, which, since this language is very simple, there's only doubles. So I'll do that. So I can remove this. Keywords, though, I'll keep, because there's just too many. But for this, I will make a micro mental overhead optimization, you could say. Right. So I need to make sure that this is updated as well. Where's the error type? Here. Landed perfectly on it somehow. That takes a string, and then Yeah, so let's run. Use a moved value string where 109. 109. Right, that's actually a mistake. This should continue the loop. Looks good. So let's try adding a string literal. Not equals Kojo Bailey. Very creative, I know. Yeah. Again, I mean, you can't see because my camera's blocking it. Maybe I can do this. Yeah. So it's taking the string literal, but it's including this first quotation mark. So start needs to be +1. It would appear. So start is this +1. Try again. Okay, now it's correct. It's just a Kojo Bailey. Take my word for it. And then if I change this to say, actually, how about I just move my camera here? It's a bit awkward, and my Activate Linux thing is blocking part of the screen. It's a bit awkward, but that might be okay for some things. I'll move it back if it's a problem. Yeah, so that's fine. As you can see down here, we got Kojo Bailey, and then if I have an unterminated string, like so. It works, yeah, sorry. I was trying to see what the hell's going on here. Then I get unterminated string, Kojo Bailey. Perfect. Literally perfect. And just check if I add like other token symbols here, then it shouldn't pick them up. Yes, correct. Nice. Well, pretty straightforward. So now, we need number literals, right? So like with comments, you can assume characters hit the thing. We're also gracefully handling running out of input. For no particular reason, not supposed to multiplying strings. There are pros and cons, but printing them was more complex than allowing them to let them in. Yeah, I mean, not hugely, but... Ooh, I do need this though, actually. Where if we hit a new line, we need to increase the line number. And that's pretty easy to do. I'll just add it to my advanced until. If self.get current char equals a new line, then self dot line number plus equals 1, right? No, self dot current line number. Okay, so that means if I have like a split, it will increase. I think that's how it works. Anyway, the last interesting bit is that we create the token, which will produce the actual string value. Okay. Then we have number literals. All number literals are floating point at runtime. So since you look only for digits to start a number, that means -123 is not a number literal. Instead, -123 is an expression that applies negative to the number literal. Okay. Though it has one interesting edge case. If we were to add method calls on numbers like this prints -123 because negation has lower precedence than method calls. So the solution here is to use brackets. But yeah, that's... Yeah. We don't allow a leading or trailing decimal point, so these are both invalid. Okay, we could easily support the former, but I left it out to keep things simple. The latter gets weird if you want to allow this. I agree. To recognize the beginning of a number lexeme, we look for any digit. It's kind of tedious to add cases for every decimal digit, so we'll stuff it in the default case instead. When would you even put a dot? I'm just trying to think. Right, yeah, sorry. This I do sometimes for like on like, you know, in like a calculator. But I never do this. For obvious reasons, you don't need to do it if you wanted to declare a float, but at that point it's better to use a float literal suffix with like f. To recognize the beginning of a number lexeme, we look for any digits. It's kind of tedious to add cases for every decimal digit, so we'll stuff it in the default case instead. It is tedious in Java. It's actually very simple in Rust. So for Rust, we would just do this. By the way, if you think I should wrap this in a function, I might later. Don't worry, or do worry, because I might not do it. So if this is, we're matching anything within a range from 0 to 9, including 9. I don't know how to do that. Equals. Thank you. And I don't even need the braces. Holy moly. And then anything else after that doesn't matter. This is another special case. It's got an isDigit boolean. The Java Standard Library provides character to isDigit, which seems like a good fit. Alas, that method allows things like Devanagari digits, full width numbers, and other funny stuff you don't want. Oh, I see. Okay. Once you know what the hell are Devanagari digits? Sounds like something Indian or. They're used to write languages like Hindi, Marathi, and Sanskrit. I see. Once you know we are in a number, we branch a separate method to consume the rest of the literal, like we do with strings. He uses parse double. So yeah, very much just like a thingy. So same thing really. Let's start equal tokeniser dot current char index. In this case, we want to include the digit, so we're not going to +1. They would do tokeniser dot advance until. Then here, this is more complex, so I'm not gonna have a function for it. Instead, I'll just do while. Well, first of all, while tokenize not tokenizer dot is at end, but also and tokenizer dot get current char. Is it like an element? What's the equivalent? What's the Rust equivalent of Haskell's? C is an element. C is an element of 0 to 9, basically. That's built in, is it? Does ASCII digit also include period? Okay, so while the structure is ASCII digit, or c equals dot, and I'm going to change this. So let c equal tokeniser dot get current char, then changes here. C 2t dot c dot is ASCII digit or c dot it. Then tokeniser dot advance. In this case, we're not going to support multi-lines. Okay, and then we're done. You do let end equals tokeniser dot current char index. This time we'll do -1, so we don't include the closing. Oh, sorry, +1. So we do include the last number. Then I think that's it. I don't think there's an error here, is there? This doesn't mention it. So then we just do tokeniser dot add token, token number literal, and here we need to parse. Does Rust have a parser for string to float? It shouldn't be invalid, so I can just unwrap it, I think. So do let's, well, first of all, let's numString equals string from iter tokeniser dot source start to end. To be fair, I don't need +1 because I can just do equals instead. And then do let num which is num equal numString dot parse dot unwrap, and I need to include the type, and then pass it in here. Compiles. So let's have a look with a number. I'll just stick one like here, 5.34 plus 9.93, let's say. I got panic. 126. Range end index 59, out of range for slice of length 59. Out of range. I think because of this, these have been brackets. Nope. I mean, yes, but I think that is relevant, but also, or maybe not, I don't know. Tokeniser is at end, and C is ASCII digit, or C equals this, advance. Right. I know it's wrong, by the way. Hold on. Let mutable c yeah, it's like that. Ooh. Now I've got an error value apparently. Let's debug this. I won't compile the willet. Is it shit? Is it like assert in Rust? Can I assert? How do I print at compiled type? Never mind. Wait, what? Hold on. Oh, right, because it's running. Yeah, no, sorry, it's runtime. So let me print line num string. See what comes of it. You serious? Actually, it makes sense for consistency. 5.34. But it's saying that parse float error is invalid. Why is it invalid? What is the error? Match. Just there's definitely better to do this, but just really quickly, parse. If it's an error, e, then print line. E. Cannot infer type. Shit. How do I? Can I add it here? Nice. Invalid float. Okay. Invalid float roll. Why is it invalid? I don't understand that. Is there a space after it? I can't tell. To make this a bit more clear, let me just remove the spaces here. Yes, there was a space after it. Okay. So J end. So I need to actually exclude the end, I guess. Yep, now it works. Okay. So we get token parent start, asterisk, all that stuff, minus bang. Then we get 5.34 and 93.0, which is correct because they're both floats. Nice. Cool. That works perfectly. Looking past the decimal point tries the second character of look ahead, so you don't want to assume the dot. Oh right, so if there's no digit after it, it shouldn't work. So right now, if I do just 93 point like that, it will still work. When it shouldn't. That should be an error. So or c equals this and c dot next char dot is ASCII. What? Man, it's actually really. Okay, hold on. CC and NC for current char and next char. Sue me. I know that's horrific. Tokeniser dot get next char. Just copy this. Literally. And then we'll say CC is ASCII digit or cc equals this, and next char equals next char dot is ASCII digit. Unclose limiter on line 117. What are you on about? Here. Yeah, I think so. Whoops. Okay. Must be attached to each individual binding. Method not found in option char. Whoopsie. Is it like an is okay? Is there a built-in function for method for function for option that returns false early if it is none, but otherwise returns whatever is inside the option? Fuck. Nah, that definitely won't work. Unwrap or. Like unwrap or false? No, because that doesn't work. Damn it! Okay, just a new idea. We'll do let's cc. Yeah, so I want to keep this, and then I'm gonna move this here. So if cc dot is ASCII digit, and if it's not an ASCII digit or cc equals dot, then break. Otherwise, if cc does equal a dot, but next equals does not equal ends and nc dot is okay, and so if it's not, this will also just fail. nc dot is ASCII digit. Unwrap. Wait a second. Next, the next one should always be okay because this has, well, maybe not actually. Okay, then fine. Close that. Then also break. Okay. Hear me out, chat. Hear me out. Oh my god. Let me remove these. No method name is okay. Huh. I thought there was. Is there an is okay method? Oh no, it'd be is some. My bad. Is some. It worked. Holy moly. So if I do... Wait, so that'd be an error though, right? Still compiled. Fuck! Why? Because we allowed it to. So this should be an error. Right? Surely. Or is it followed by a dot? It's not followed by a dot. If I do double dot, and I get an unwrap error. Yikes. Oh my days, this got complex fast. So we want the current char and the next char. If the current char is an ASCII digit, sorry, if it's either not an ASCII digit or not a dot, we break. So sorry, if it is neither an ASCII digit or a dot, we break. Otherwise, if it is a dot, but or and the next character is an ASCII digit, is not an ASCII digit, sorry, then break. Okay, there we go. Okay, so this should fix this issue, first of all. You get a period. But it should be including 2 periods, but it's not. Uh-oh. Don't know why. It's not advancing. Oh, because the current char is a dot. I see. So here we actually want to backtrack. It's a bit weird, but I'm going to do it. In fact, I'll just make it a thing. Tokeniser dot backtrack. I know it's strange, but it's like the easiest way out of this, so I'll just do it. So you go advance, and we go backtrack, which is the opposite. Could call it retreat, but that sounds like it's fucking military. So self dot current char index minus equals 1. Nice, now it works properly. Bro, why is it now 9? You seen that? It went from 93 to 9. What? What? So if I backtrack, the 3 just disappears, but the period reappears. What? Hold on. What's going on? How about I just do this then? Token... No, because it'd be the end, wouldn't it? Fuck! Okay, I can do this. Let's mutable... does end with period. False. This will become true. And then we say if does end with period. Does end with period. Then tokeniser.add token period. So basically we just like hack it, fuck it, add it ourselves. Not the most graceful. Could probably make this a lot better, maybe, but for now that will do. Right, and then what's next? Reserve words and identifiers. So hold on, I need to go somewhere soon. Friends will be pre-in for a night out. What the hell? The remaining literals are booleans and nil, but we handle those as keywords. Okay, so reserve words identifiers. Our scanner is almost done. Hold on. I could have made peak take a parameter for the number of characters and had to look instead of defining two functions, but that would allow arbitrarily far look ahead. Okay. Our scanner is almost done. The only remaining pieces of lexical grammar to put identifiers and their close cousins. They're the reserved words. You might think we could match keywords like or and see when we handle multiple character operators like this. Okay, I was not thinking that. Consider that what would happen if a user named a variable or child. If a user named a variable or child. The scanner would see the first two letters and immediately emit an or keyword token. This gets us to an important principle called maximal munch. When two lexical grammar rules can both match a chunk of code the scanner is looking at, whichever one matches the most characters wins. Is this valid? Okay. The rule states if we can match orchid as an identifier and or as a keyword, then the former wins. This is also why we tactically assumed previously that this should be scanned as sequence token and not this followed by this. Maximal munch means we can't easily detect a reserved word until we've reached the end of what might be an identifier. After all, a reserved word is an identifier. Yep, it's just one that has been claimed by the language for its own use. That's what the term reserve. Okay, so we begin by assuming any like seems to letter underscore is an identifier. So is alphanumeric advance add token identifier? We define that in terms of these helpers. Okay. I'll just define this as a function real quick. A helper function. So hold on. Function is alphanumeric. Is that what it's called? Oh no, that means is alpha or is digit. Fair enough. So is alpha. Some char. Just a bool. It will say C okay, so A to Z inclusive dot contains char or A to equals Z dot contains char or C equals dot underscore. Yeah. Now it makes sense to put the C this part first because that is the least expensive check, right? Okay. Now I could collapse this to be fair. I think I will. Okay. So we got that, and then for function is alpha numeric. Is that one word? No. At least not there. Numeric char c bool. And simply check is alpha c or c dot is ASCII digit. Okay. Two useful functions there, helper functions. So this is in our place here, right? So if is alpha equal to c. If is alpha, in fact, yeah, let's just do that there. If it's alpha, then do something else. Otherwise, fail. Or reverse condition, if it's not alpha, then do this and continue. Otherwise, ah! Otherwise, handle. Okay, actually, there's no point in reversing this because there's no early return. So if it is alpha, we will parse identifier. Or like this, I guess, tokeniser dot parse identifier. Okay. This case identifier is working. Title keywords. We see if the lex scheme is one of the reserved words. How are we getting that? While is alphanumeric. I see. So down here. So function parse identifier. Ooh, to be fair, I don't want that to be part of the tokenizer though. Okay, I'll just do this instead. While not tokenizer dot is at end and tokenizer is alphanumeric c let c equal tokenizer dot get current char at the end, tokenizer dot advance. This should shadow it, I think. It might not. No, actually, it probably won't. Just do this. Yep, advance. Like with the number. Let's start equals tokenizer dot current chart index. And let end equal tokenizer dot current chart index as well at the end. And then parse identifier. The identifier is going to be string, so let identifier equal string from iter tokeniser dot source start to end, and then pass that in here. Like this. So that would just be a private function. In fact, I'll call it a match identifier. Takes a string, but I can just take it as a reference instead. It's void. Okay. And then just match it. So match identifier. And it's strings, right? So like if it's, I mean, what way list? And, class, else, false, all the good stuff, right? So like and would be token just borrow the tokenizer. Immutable reference. So how does this work? Like, do I do it like this then? At this point, you may wonder why I don't just put it into the tokenizer. To which I say, good point. So self dot add token. Token colon keyword colon and, for instance, and so on and so forth for the rest of them. Yeah. Alright, so now just do all of them. So we got what? Class, else, I'll just later, else, false, for fun, if nil, or print, return super this, true var while. Okay. So false, for fun, if nil, or print, return super this true var while. Okay, do a bit of alignment. Is there like a way to automatically align these? I do wonder. Where's the voice call? Oh no. Hold on, chat. Might have to take this in a second. Right, so print is a keyword in this language. Okay. And then if it's anything else, then we say it's probably an identifier. So self.add token identifier, and that's just a string, right? Yeah. This file's getting a bit big, so I might split it up into different things. Identifier. Cool. Give that a run. Whoopsie. Got a C star definition here somewhere. Should be C char for both of these. Uh, 148 is alpha expected char found char option char. All right. Put just like this then. Just disregard the next char. Arguments is in value incorrect. Found stir. Okay, fair enough. In my case, I'll just make it. Just move it. Nice smooth semantics in Rust. If I make this a string, then I'll just move into it and take ownership, and no performance loss. I don't think. Oop. Never mind. Alternatively, I'll do this. String from. Self is a reference, so it can be borrowed as mutable. Alright. Cool, that works. So these are keywords, right? So if I go to my thing, let's do 93 minus foo and var Kojo. So foo and Kojo should not be reserved, but and var should be. We'll do var if Kojo. Okay, well, what do we get? Print start plus asterisk print end brace start minus bang bang literal plus 93, then a period, then minus, then identifier foo, keyword and, keyword var, keyword if, identifier Kojo. Absolute cinema. So that works. That's it. Keywords are done. And with that, we now have a complete scanner for the entire log statistical grammar. Fire up the REPL and type in valid and code as many times as you expect. That's awesome. That actually worked. That's done. So I'm finished with the lecture. So now I'm just going to clean it up. The lexical grammars of Python and Haskell are not regular. What does this mean and why aren't they? Aside from separating, okay, let me read this. They're not regular. They don't follow regular expressions, I guess. Aside from separating tokens, distinguishing print foo from print foo, spaces aren't used for much in most languages. Alright, let me also test that. So var if should be not a keyword. Nice, that works. However, in a couple of dark corners, ouch, a space does affect how code is parsed in CoffeeScript, Ruby, and the C preprocessor. Where and what effect does it have in each of those languages? I don't use CoffeeScript or Ruby, but in C, it will replace stuff matching on white space as well. Our scanner here, like most, discards comments in white space since those are needed by the parser. If I wanted to have significant white space, I would use that. And to support Lox's scanner for C-style block comments, make sure to handle new lines in them. Consider allowing them to nest. Is adding support for nesting more work than you expected? Add support to Lox's scanner for C-style. Oh, so this is a challenge. Okay. One segundo. If I add block comments and allow nesting, then it will only look for the last closing thingy? How's that work? Oh, it's nesting. So like you like count the nesting, I guess. I could do that. I think I will do that. But not now. I'll do it later. Because I want to go out. Parameters today are spoiled for choice in language. I've gone picky about syntax, when the language should look clean and modern. One bit of syntactic lichen that almost every new language skips off. Semicolon. Bam, 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 bam. Is value being returned, or do you have a return statement with no value followed by a statement containing string literal? Lua ignores new lines? I didn't know that. That's horrific. Weird. Go handles new lines in the scanner if a new line appears following one of a handful of token types. Yeah, Go has no semicolons, right? Python treats all new lines as significant unless an explicit backslash is used at the end of the line. Yeah. And you know why Python's lambda allows only a single expression body? Okay. I haven't used lambdas there. JavaScript was so fucking weird. If you're designing a new language, you almost surely should avoid an explicit statement terminator. Programmers are creatures of a fashion like other humans, and semicolons are as passé as all caps keywords. Just make sure you pick a set of rules that make sense for languages, particular grammar and idioms, and don't do what JavaScript did. Okay, so when I come back to this, I will, when I'm finishing up my parser, Lexer, sorry, I will also implement this challenge. Until then, though, I'm going to just go ahead and commit. Whoops. What did I do? I don't know. I'll probably press enter. So anyway, so git add all, git commit, implement or well, not implement, finish Tokeniser, mostly, and push. That's it. Circ. So that's done. Good progress today. So yep, I will continue this later. By later I mean like tomorrow, and that's it really. I'll do this challenge, and then I think we go on to the next stage, which is representing code. Okay, I don't know what that means. Is it parsing? Is it not? Who knows? We'll find out. So subscribe to join me on that journey as we go on yet another Kojo's Bizarre Adventure.